I just did, so you multiply this, so you have the.
Oh.
And 35 miles is out, there's how many minutes.
A high school picture.
I don't know how many, but.
Oh, thank you.
Yeah.
Well,
Yeah.
vintage, yes. Yeah.
We find the number. And then one, last time we use 6 zeros. This is mine. And then you divide that by. Yeah, because yeah. Oh. When you get 50 or something.
Okay. So how are we supposed to do this? What have you learned to do something like this? What's the process? In chemistry, what's the process called? Do you remember? Stoichiometry. So we're gonna take this 35 miles per hour and write it as a ratio, right? Nice. So 35 miles like this per 1 hour. Is this what you're used to? And then from here, yeah, if we want to get rid of those miles, we're gonna put miles on the bottom. So it's gonna be 1 mile. 1 mile is equal to 5280 feet. So now we have, if we do this, it's gonna be feet per hour, which makes sense. It's gonna be a lot of feet. So next we're gonna have to cancel the hours by putting 1 hour on top. And what should we put on the bottom? We could either go to minutes or directly to seconds. And in 1 hour is 3,600 seconds. Are we comfortable with that? So now the hours cancel, and if you were to crunch the numbers, I know it's going to be feet per second, but the number is going to be 51.3. I think that's what it is. So if you didn't get that, just make sure that you're able to get it with your calculator. Is it 3 repeated?
Yeah.
No, let's just make sure it's exact. Okay. Any questions?
No.
Nice to see a little bit of what you've done in chemistry in your Algebra 2 class. Cool. Who knows? Maybe there's be some more of that at some point. Dun, dun, dun. Maybe. Hopefully. Oh, you like chemistry? Love chemistry. Oh, yeah, good taste. I'm glad you like it. Okay, so today is the beginning of a new packet, and as with the beginning of every new packet, we look over it. Yeah, we have one quiz. You see, it's only 5 days, so only time for one quiz and one test, of course. So our quiz is going to be on day 4, covering day 43. What's that?
Ours says unit 6.
Oh yes, and thank you. This we just finished unit 6,
Oh.
so please change yours to unit 7. Thank you for noticing. I meant to say that. Good catch. Okay, so yeah, we're going to be talking about trigonometric functions. Go ahead and say that word, trigonometric. It's probably the most fun word in all of math, at least. So let's get right to it. And before we get into concepts, I know last year, I believe most of you had a class called geometry. Would you please discuss exactly the definition of an angle? What's an angle?
You can go for some. 1, 2 seconds. And more. Right, okay. 1, 2, 3 seconds. No, I'm running equal. 2 lines. No. Somebody could be like, no, a line doesn't. But it could be a number and a line, a ratio. Outline.
So, other classes, students have said that an angle is a pointy thing. I think they're not wrong. But in terms of definition, it's probably lacking a little bit. In other classes, they said an angle is what happens when two lines intersect. What do you think? That's okay, but if two lines intersect, Is that an angle? Two segments. So if two segments intersect like this?
Intersect the vertex.
And, well, first of all, let's discuss this situation. What's wrong with saying that this is an angle? It has angles. Exactly. How many angles are there? There are four. And just as a little refresher, remember that angles 1 and 3 are called something. One and three. 1 and 3 are called vertical angles. And you remember that vertical angles are congruent. Congruent. Yes, I heard that. And yeah, angles 1 and 2 are supplementary. Did they talk about linear pairs, like angles 1 and 2 being a linear pair?
What? Yes. Yeah.
They mentioned that? Okay. Okay, so there are a bunch of angles here, but we can see that the definition of an angle as two lines intersect falls flat. So what actually is an angle?
Base.
What's that? A base? The space. Right? The space between what? But first, I want to know what an angle is.
Measurement. Yeah.
A measure is one way to, well, measurement is a way to measure an angle, but not, like what's the basic ingredient for an angle?
The vertex.
What's that? A point and two rays. Do we agree? A point and two. Do you remember what a ray is?
Yeah.
So if I have this ray, do you remember what this point's called? That's what's called the vertex?
The endpoint?
It's called an endpoint. It's kind of strange because that's where it begins, in my opinion. So if it's two rays and an endpoint, sorry, two rays and a point, is this now an angle? I have two rays and a point. Connecting rays. Okay, so I have to do this. Two rays connected. Two rays with the same endpoint. Yes, that is the definition of an angle. And you don't have to write that down. I'm not going to test you on it, but I think it's just interesting to know that. I know that you all know what an angle is, but to formalize it, so and imagine that second ray is the string. I'll try to make the string. That's just terrible. Still not with it. Okay, so that is an angle. The common endpoint is called the what of that angle? It's called the vertex of the angle. And when we measure it, up until now we've been measuring what we called degrees, and degrees measures what about the angle? Would it make sense to say a difference of direction? Does that make sense? It's a difference of direction. It measures like how far apart are they, like pointing. Okay. And you know what acute angles and obtuse angles are. So today we're going to be talking a lot about angles, and specifically in this unit, we're going to be talking about angles in standard form. So Bertie, you ready for this? Angles in standard form. Well, every angle has two sides. It has what's called an initial side and a terminal side. Yes. Initial side, we were talking about standard. Always, do you see where the initial side is? It's always pointing to the right. If it's on a coordinate plane, it start at the origin and just point to the right. So that's the initial side always, and the terminal side is somewhere else. Now notice all these three angles they do appear to be acute, and they also appear to be the same, don't they? Do you agree they appear to be the same? But notice how these are measured. It's measured three different ways, and it's introducing some Greek letters. Angles are usually depicted with Greek letters in mathematics. So this first angle, do you know what letter that is? That is an alpha. Go ahead and let's practice writing an alpha just to get that in our vernacular. Just do a couple so it feels comfortable. Yeah, it's kind of like a fish. What's that? Oh, does it? I don't know that. Oh, interesting. Oh, more chemistry. Yes. Okay, so that's alpha. This letter is beta, which I think is the prettiest. I really like that. No offense to the other letters, but it just To me, it seems like a butterfly. It's just so nice. Yeah, like just kind of like, and not really a butterfly, but and you can, I don't know. Oh, thank you. Like a butterfly that's been ripped in half. It's so pretty. Sorry. Like a dust. It does look like a duster. Yes. Okay, and this other letter is it is delta. Delta. I've never seen it anywhere except for on this paper, but um, alpha and beta we'll see it pretty often, especially next year. But yeah, delta looks something like that, or an ayin if you speak a little bit of Hebrew. I think that would be an ayin if you know the alphabet. And the one that you normally used for angles would be, do you know the letter we normally use for angles? What's it? Theta. Yeah. Do you know what theta looks like? Theta looks like an O with a line right there. What's that? Yeah, when it has a meaning. I think there's a lowercase and capital. Right. Ooh, nice. How do you know this? Chemistry. Here it is again, chemistry. Okay. Anyway, those are the letters we're going to be using, but more importantly is how is this measured? When you're measuring the angle, it always comes from the initial side and goes to the terminal side. Now notice in this first one, case, this is the direction is counterclockwise. And this counterclockwise is said to be a positive angle. As opposed to the next one, what's that best? The next one, you see, we still start at the initial side. But it's going to the terminal side, same place. This time it's clockwise, and it's considered negative. That's when we measure, so up until now, I think you haven't had negative angles, is that right? It's kind of strange. So yeah, we have positive angles measuring this way, or from the initial side, negative angles measured from the initial side going clockwise. Not only that, but we could have angles that are more than 180 degrees. And we could have angles that are more than 360 degrees, like that last one. Is that positive or negative? Are you sure it's positive? How do you know? Well, it says that's counterclockwise. It's counterclockwise. And that's one of the reasons the quadrants are in the direction that they go 1, 2, 3, 4. It's one of the positive direction of our angle. You see what I'm saying?
Yeah, it's not perfectly around my foot. I don't know
how. It's just opposite of clockwise.
Yeah, I don't like that. Yeah, that's what I.
It seems unfair, doesn't it? Yeah. Yeah, get used to it, I'm sure. But you can see that this angle is actually more than 360. Yes. I guess just living one time or ending right there.
So why would you want that?
Why
do you want one go for the terminal side and
one question at a time. Why do you want this? What we're doing is we're taking the idea of an angle and abstracting it, so it's no longer just 0 to 180. Like why stop at 180? And why stop at 360?
That was fine.
It would, yeah. Well, this plus 360 would equal. All three of these angles are called coterminal. Does that make sense? Coterminal because they have the same terminal side. Don't they all have the same terminal side? If they're the same angle.
Oh, what about the half there? Oh, I don't know.
So, well, all we're doing here is we're measuring like what direction is that going from here? I'm going to use my animation skills right here. And right here is my terminal side because it can move. Okay, so terminal side. Okay, I've gone 90 degrees, and now I've gone 180, 270, 360. Here I'm at terminal. So this is just how it's measured, that angle. Why? For reasons of application in science later on. Maybe chemistry. Yes.
For when you go all the way around, it would be like 360, right? But
Yeah.
a little bit more would be like, let's just say it's 30 degree angle and 4, 10, or something like that. So would it be negative because it's counterclockwise? Or sorry, positive?
Are you
Like, perceived, so would it be like positive 45 degrees?
Well, I like what you said. Like, let's say that this first one is 30 degrees. If this first one's 30 degrees, how much would this be? 360 plus 30.
So yeah.
So 390.
Sorry, I don't know why I said that.
No problem. You're the 10 away from the
Yeah.
400, I think. Yeah, but you're right. So just go another 360. And we'll do a bunch of practice, but this is just the idea. Positive, negative degrees, and we could go into past 360. Yeah. It could be infinite. It could be 1,000 degrees. Hot, isn't it? Yeah. Okay. Any questions? Perhaps your question is, let's proceed. Can we proceed? We're gonna proceed here on another sheet. I have something for you. There you go. There you go. Okay, so it's about to feel again like it's second grade, kind of like last time. It kind of felt like second grade last time, didn't it? You had scissors, you had things you could make little creatures out of. Was it refreshing? Like lemonade? So what I'd like you to do here is your first job is to very simply cut this first one into 2 even pieces, cut the second one into 3 pieces, 4 for this next one, and for the last one, let's cut it into 5 is a good guess, but instead of 5, we're gonna skip 5 because can you imagine doing 5? Let's do 6 though. So go ahead and do your best job of cutting these evenly into 2, 3, 4, and 6 slices. We'll do the back later.
So just like draw it out.
Yeah, go ahead and draw it.
We use them.
Oh, just sketch it. You can use a ruler if you have one, but just eyeball it. Check the accuracy of the neighbors, so we can just kind of compare what we've done. The hardest one's probably which one? 3 for sure. 4 is also tricky. Right. Yeah. Did you guys finish? Can you show me the cuts that you made to divide into 3 pieces? Yeah, exactly. So each slice is how many degrees? How many? 60 degrees. Does that make sense? Each one of these has to be 60. Something like this. For 4, the first cut that you made is hopefully, yeah, cut it in half. And then half again. So whereas the last one was all 60 degrees, each one of these would have to be 45 degrees. Yes? Yeah. And this last one, the first thing we should cut is half again because 6 is an even number. This just seems off. Is it dot off? Yeah. The dot may be off a little bit. That makes sense. And now each side is going to be cut into 3 slices. So whereas we had 45, sorry, 60, 45, this one's going to be each piece is 30 degrees. So something like this. Please forgive my squiggles. It's purely technology. And I'm gonna go ahead and use ideas from today. Like this is 0 degrees. Up at the top, I'm gonna label that as 90 degrees because I'm just measuring in standard position. And then I'm gonna finish that off with 180 degrees. Is that comfortable? So please do that for 3, 4, and 6 as well. Exactly. Yeah, if you put the 0 here, there's really no other way to go except for time. Make sure your neighbor got all the right numbers. You good? So like for 3, we have 0 degrees, and we have 60 degrees, and we have, after that is 120 degrees and 180 degrees. And that 120 really represents, you don't have to write this, but it's just representing this angle, this with this, right? This is all standard position. So from that initial side to the 120, to that second cut is 120 degrees. For 4, I want to know all the degrees, not from Jake, though, because he's not here. We miss you, Jake. But Mia's here. What are the degrees for here? We start with 0, 45. Maybe, was that pretty easy? Okay, could you do the next one too, please? Any questions? No. Easy peasy? No. Something brand new for which I need your 100% attention. Last time we revisited 2nd grade, for what reason? Do you remember I think one of the questions was, how many of those radii, when you cut the radii, how many did you need to go all the way around this circle? I don't remember what you had. About 6-ish, is that right? And it didn't matter what size circle was. Does that ring a bell? Yeah. So the actual answer, do you know the actual answer is to go all the way around? 6.28, which is 2 pi. So instead of measuring degrees now, we're going to be measuring what's called radians, where 360 degrees is equal to 2 pi. 2 pi, and I'll say radians. But really, when I say 2 pi, it's automatically radians. If there's no indicator of units, then it should be. Yes, that's exactly. Well, the area is pi r squared of the circumference. Yeah, but it's all related to this. And by this measure, 180 degrees is equal to pi radians. Yes? So now we're going to do this problem again. I'm going to start with the 4th one. We'll do this together. And actually, after you write this down, I'm going to ask you to put your pencils down. And I'm just going to work on 4 for now. So I'm going to label that as 0 radians over there. And 180 degrees, I know, is pi. Now, this top part is cut into 4 pieces, isn't it? So does it make sense that this first piece is just going to be pi over 4? And the second piece is going to be 2 pi over 4 because we have 2 of them. And the third piece is going to be 3 pi over 4. And the last piece is 4 pi over 4, which of course simplifies to just pi. And you're probably annoyed at that 2 pi over 4, aren't you? It's like You're probably thinking, is he gonna leave it like that? No, I'm not gonna leave it like that. It's instructional purposes only. This is pi over 2, which also makes sense up here, doesn't it? Because this is pi, so of course this would be pi over 2. So take a moment to fill those in and fill in all the rest of these. You need to say the same thing tomorrow. Both ways. We'll be calling 2 people to help me out with these. Are we ready? Okay, Charlotte, can you help me with the 3-piece one? Okay. Any questions? Very nice. So we just found out that pi over 3 is the same thing as how many degrees? 60 degrees. Yes? And 2 pi over 3 is the exact same thing as 120 degrees. It's like 2 different languages. Nicely done, Charlotte. Thank you. Merci. De rien is you're welcome. I'm surprised that a Parisian doesn't know how to say you're welcome. Interesting. Oh, that's so sad. Okay, Lucy. 6. I'll do 0 for you. Can you tell me how you got these numbers? Oh. Yeah, where did that 5 pi over 6 come? Like, where did that 5 come from? So you're quite skilled at counting, is what you're saying. Oh, nice. Are we good with that? Any questions about this? This one, and I love how you refer to the other one. But I hope that you can see if you're building it from here, you can just say 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then simplify quickly as appropriate. Any questions? Perhaps your question, what does it live? Yes, in fact, how about this whole circle? For this one, you're going to divide top and bottom into 4 slices, which means it's going to have how many total? 8 slices, and this one on the right, 6 on the top, 6 on the bottom, for a total of 12. And I want you to label each piece with degrees and radians all the way around to 2 pi billion. Or pieces. The first one is 8 slices, the second one is 12 slices. Come on, take people out with this. In a little bit, so make sure that you are ready for that. Oh, yes. Thank you. Degrees and radians, please. Ready? Looks sad. That's that behind the neighbor in front of you, behind you. Your respect. Last time, over. There is no over 8. Are we ready? Ready now. Let's do this first one together. We know that. Are we okay with that 0 on the pi? Are we comfortable with that pi being 180? I hope so. That's kind of a home base, in my opinion. So this first place is pi over 4. Why is it over 4? Well, why are we doing why is it pi over 4? It's kind of 4 pieces on the top, right? And then the second one, instead of 2 pi over 4, pi over 2, and then we have 3 pi over 4. Now, where would pi over 8 be? Is that a thing?
2 pi.
No, where is pi over 8? Would you have to cut that into? Yeah, when you have to cut up the top into 8 parts. So it's the pi over 8. Do you see what it would be? It would be exactly. It'd be at pi over 8. Where is it, Mia? right in between 0 and pi over 4. In fact, it's just half of pi over 4, isn't it? Half of pi over 4 would have been pi over 8, but we're not doing that. We're not cutting into eighths. Okay, so I've gone up to pi. Who can help me count the rest of the way? Lucy, thank you. After pi. 4 and 2 pi. Can you tell me where that 3 pi over 4 came from? Oh, so I think you did say 3 pi over 2. I'm sorry. Can you tell me where the 3 pi over 2 came from? 6 pi over 4. So it came from your amazing counting skills. Are we good with that? It's still over 4s. 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Yes? Oh, good question. Why does this party have to end? Yeah, we could keep going. After 2 pi would be... Oh, yeah. 2 pi. Oh, because we've gone 360. Come back to this. So 0 and 1, 2 pi is silly. I would say the set. Let's see. Now, this is a good question. Like, this is our initial side. We know this because it's a standard form. And then the question is just how far is this other one? Right, so right now we've gone pi over 4 radians. Pi over 2 radians. 3 pi over 4 radians. Pi radians. And if we go all the way here, we're back to the beginning, which means we've gone 2 pi radians. Which, yeah, it's weird to have a 360-degree angle, but it is the same thing as 0 degrees. Are we good? Lucy, that was fantastic. Appreciate your help. Are we ready for this next one? Can I call on someone? Do you need a moment? And ready or not, let's see what you got. Avery, we're already okay up to this pi. Can you help me after pi? Remember, we start with pi over 6. So after pi. So after pi, because we already did the full top. So keep going after pi. In other words, right here. Nice. Okay. 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 Are we good, everybody? And hopefully that 11 makes sense because there's a total of 12 slices. Each one's a 6. Avery, that was really nice. Can you tell us how you got that 4 pi over 3? So your counting skills are on point. I appreciate that. Any questions? Is it difficult to do these in degrees? Quite easy, isn't it? You're either adding 45 each time or adding 30 each time. So I'm not going to go there. But hopefully you fill those in. Okay, let's move back to the package now. I like that. Okay. It says there's a couple different things here. I want you to draw each angle, please. In what position? Standard position, which means the initial is going to look like what? Bam, it's going that direction. Exactly. It's just a learning. Unlike they're going to say draw these angles. Just the angle. For the main ingredients of the angle. Things, yes. Do what? Raise. Yes. first, find your first negative angle and your first angle that's more than 100. Way more than 100. Draw. That's Are we good? Would you please take your pencil and, or, yeah, your pencil and hold it so that it's a terminal ray for the first problem? Okay, so your hand is at the vertex. It's looking like something like that. And did you tuck a 45 degrees in there to make sure we know that? Okay. Should I do this to make sure we know that that's what we're measuring? It's kind of implied because 45 is positive and we're in standard form, so there's no need to have it there, though you may. Negative 90, would you please show me where the terminal side is? Very nice, it's pointing straight down. Why is it going down? Yeah, because we have to go in a clockwise direction, 90 degrees. That gives us that negative 90, which is just weird. Like, are you supposed to have a box there, or how do you? A box would be appropriate, but we're labeling it for that negative 90, and there's no negative box. For 420 degrees, would you please show me where that is? Where does it land? Nice. So what I'm seeing is that we started here and then we proceeded. I need to connect to that point. Okay, so we proceeded this way. Right now I'm at 180, 360. How much more do I have to go? 60, so right about there-ish. So 420, I can't just tuck in there. In this case, I am going to put, yeah, I'm going to do this. Would that make sense to do something like this? Oh, not a circle. So 420 degrees. Next, it's asking to state one positive and one negative coterminal angle. Now, coterminal means it's the same angle. It's just a different way to get to that terminal side. Like, what's another positive angle for that first one? Well, let's see. Let's do this together. Okay, here, this is 45 degrees already. Yeah, so I'm just thinking I have to keep going there positively. And now this is how many degrees? Does that make sense? 405 degrees is a coterminal angle with this. It ends in the exact same place, but it's a different angle measure. So 405 degrees is a positive coterminal angle. Would you find one that's negative as well? Coterminal. So it ends, it's gonna be the same angle, but you get there clockwise. I'd like to hear your answer on the count of 3. 1, 2, 3.
Negative 4.
Negative what? 3. 25. Yeah, so yeah, let's talk about this. So the question is, if I go negatively, how far do I have to go to get here? Now, it's definitely less than negative 360, isn't it? Because negative 360 would take me all the way here. So it's actually negative 360 plus 45. Oh, is it 315? Yeah, I think you're right. Thank you. Yeah, that should be 315. And we could have just done 45, and to get that 405, add 360. Or we could take the 45 and subtract 360 for the other one. Does that seem reasonable to get those quickly with calculation? Any questions? Perhaps your question is, could we try the next two? The answer is yes. Yes, you may. One positive, one negative. There's an infinite number of possibilities, by the way. You're on B and C. B and C. Sorry, you're on B and C. Okay, so negative 90. Yeah, Walker. How did you get that?
You go round clockwise.
Mhm.
Then, no.
Does that make sense? Oh, I like how you went one revolution first, right? That's what you did. So you did negative 360 minus 90, or 360 plus 90, of course, in negative territory. Are we good with that? We could have also started at negative 90 and then gone 360. Does that make sense also? And just another way to think about it. Either one is perfectly valid. That's fantastic. Do you want to give us a positive one also?
270.
Do we agree?
Yeah.
Any questions? That's great, thank you. So 270. 420 degrees. Fiona, help us out here. Negative 300. Where did that come from? So if you start like at 420?
Yeah.
Okay. We go clockwise. Wait a minute. So this is 420. 420. I went the wrong way. 420. And then what did you do from there? Oh, you start from here. Okay, and then okay. Negative 300. Okay. Any questions about that? Okay. Are we good with that? Because what? Yeah, it's a little bit cleaner, isn't it? 60 degrees. Any questions? Thank you. Nicely done. Let's try. Let's skip these and go to conversion between degrees and radians. Well, we know that pi is equal to 180 degrees. That's probably the most important thing for you to lock in for today.
Just get.
No. Don't exit, but we're going to do some of it, but I do want you to do examples 3 and 4 first. Examples 3 and 4, I want you to use the papers that we worked on today to do these.
They don't. Like, they memorize.
You should understand it. And we'll go over it again. When I say like use your paper, you see what I mean by 30 degrees is just the same as 5 or 6. Are we good?
Or do you want to give the positive anything?
For example, 4. Oh, if the question's positive, then I want the answer to be positive. And skip C and D, C, D, and E for now, for example 4. Skip. Yes. Yeah, does it make sense what I want for negative 135, folks? Let's take a look. Negative 135. Do you see where it is? Negative 135 is right here, isn't it? But I don't want 5 pi over 4. I want negative. Yeah, I don't want it's 25 degrees, which is coterminal with negative 135. But I want you to keep the spirit of the problem, which means instead of going pi over 4 the other direction, not clockwise, say clockwise. In other words, yeah, so right here is 0. Now, right here is negative pi over 4, yes. Negative 2 pi over 4, or negative pi over 2, taking us to negative 3 pi over 4. That's what I'm looking for now. Yeah, Avery? You would. I want to be in the spirit of the problem. So that would be, that's a different question. Renaming the angle is what that would be. And that would be perfect. Yes.
So, kind of how I thought about it is that I just went to, I did this might not be it, but I went to 135 on here and I saw that and I don't know.
Well, that's in a different place, 135 and then 135 is a different place. Oh, I see. You just, I see. So
Oh, was that just lucky?
no, that'll work every time, but I want you
I
to,
love it.
yeah, I want you to really say, oh, that is amazing. I like that. Brain. Let's see. Positive. Yeah. But instead of what remove it, so this would be, it's not too bad, right? I mean, it kind of together. Then this doesn't have- Okay, so 270 degrees is the same thing as 3 pi over 2. The negative 300 is the same thing as, nice, negative 5 pi over 3. Any questions? Okay. Oh, yes. You sure? Yeah. Pi over 3 we know is the same thing as 60 degrees. Negative 5 pi over 6. Did you get that one? Negative 150. Very nice degrees. Notice I'm marking the degrees. Why did I mark radians up here? It's implied. Yeah, you don't put any. If you really feel like I need something, then you put rad for radians if you want. But if you see it without a unit, like all these A, B, and C, that is radians. And when we go to F, we know that that's the same thing as how many degrees? 315 degrees. Okay. So 1, let's not skip this again. Let's use some stoichiometry. This is 1 what? How do you know it's radian? It's implied. So I'll put a rad there just to have something. Now I'm going to multiply by a unit conversion for radians and degrees. Radians have to be on the bottom. So in other words, we're going to have what specifically on the bottom? Pi radians on the bottom is equal to 180 degrees. So that's not a standard place. That's why we had to use that unit conversion. All the other ones were able to use what we did today. But if it's not standard, just use this. And we could have done that here, right? Here I could say, oh, this is radians, so I'm going to, actually, I'll do this with A because this is radians, so I want pi radians on the bottom. I have 180 degrees on the top. Notice what's left. 60 degrees. But we don't need to do that because we already had that. That's a standard place that we've been doing today. This is 60 degrees. We already knew that. We didn't need to do the unit conversion.
So we're just left with one.
Oh, yeah. So this is 180 over pi radians. And now you need a calculator to figure out what this is.
What?
Degrees, yeah. Thank you. Any questions? Easy peasy?
Yeah.
I do have one more thing I had to talk about today. Although this was the main thing. This is good stuff, I hope. I hope you liked it. I'm gonna take up half of this. I'm gonna put a line here. Let's talk about arc length. Do you remember what an arc is? Show me an arc. It's like if you curve your hand, that's an arc. It's a little piece of the whole circle. If you want to find the entire length of that circle arc, what would that be called? Called the circumference. And we remember, actually, could you write down what circumference is? Okay. Circumference is equal to, and check to see if your neighbor remembered. Yeah, I heard it. It's either pi d, which is really good, or equal to 2 pi r. So for arc length, and this is normally denoted by s, we're just going to take a piece of the arc. That's our piece of the circumference. So s is equal to theta over 360. This is the arc measure. Times 2 pi r. Does that make sense? It's like that's how you get an arc length. Oh, that's supposed to be a theta. That's how many degrees out of 360. Oh, it's supposed to be closed. It's like a 0 times 2 pi. Because you're taking a piece of the circumference. So this is in degrees. But how about in radians? Instead of out of 360, it's going to be theta over, well, 360 is 2 pi, isn't it? Times 2 pi r. Look what happens to this equation. We're left with s equals theta times r. So this is in radians. So if you have theta in radians and you have the radius of whatever length it is, you can get the arc length just by multiplying theta by r. Yeah?
You just
Huh?
you convert from degrees into radians.
You could always convert from one to the other if you like. But well, let me show you what we're working with here. So I hope it makes sense that the equation I just went over is the same as that which is given to you here in the packet. Right, that is equal to s over r. Aren't they the same? If we're to solve for theta. And now if we want to, and you're going to see this on the homework, which is why I have to talk about this. The central angle theta and a circle of radius 60. It gives us an arc length of 15 inches. Okay, so we have the radius and we have arc length of 15 inches. What's the radian measure of theta? Okay, so here. Theta is equal to s over r. S is 15, r is 6. That's the same thing as 5 over 2, so 2.5 inches. Yes? Okay. I do want to take a moment to look at your homework. You have about 5 minutes to do something about that. And I hope that today's material makes sense.